The snow fell in thick curtains across the narrow streets of Krinkelt, Belgium, as Sergeant Frank Wrench Kowalski crouched behind the stone wall of a bombed-out bakery, his hands trembling not from cold, but from what he was watching unfold 300 yards down the main road. It was 0847 hours on December 17th, 1944, and 5 Panther tanks were advancing in a hunting formation through the morning fog, their 75mm guns sweeping methodically across the buildings where American infantry for the 38th Infantry Regiment had been digging defensive positions for the past 12 hours. Kowalski had been a tool and die maker in Detroit before the war, a man who understood machines, tolerances, and the physics of how things broke under stress. Now he was staring at the most sophisticated killing machines the German war industry had ever produced, and strapped to the hood of his battered Jeep sat something his commanding officers had called criminally stupid, tactically unsound, and a complete waste of ordnance. 6 M9 Bazooka launchers, welded into a crude hexagonal cluster mount, their firing mechanisms jury-rigged to a single electrical trigger Kowalski had salvaged from a destroyed Sherman tank's turret control system. The concept violated every principle in the field manual. The backblast from 6 simultaneous rocket launches would be catastrophic. The structural stress on the Jeep frame could collapse the entire assembly. And the chances of all 6 rockets flying true toward a single target were, according to Lieutenant Morrison, who had tried to shut down the project 3 days earlier, approximately 0. But Morrison was dead now, his command post obliterated by German 88mm artillery during the opening hours of what everyone was starting to call the Bulge, and Kowalski was watching Panther tanks roll toward American positions that had nothing heavier than towed 3-inch guns and individual bazooka teams to stop them. He built the cluster mount in 48 hours using a cutting torch, spare steel from a destroyed half-track, and the kind of desperate ingenuity that emerges when you understand your standard weapons cannot win the fight you're about to face. The mathematics were brutal. A single 2.36-inch bazooka rocket could penetrate 5 inches of armor under ideal conditions. But the Panther's frontal armor measured 100 millimeters, nearly 4 inches of face-hardened steel sloped at 55 degrees to maximize deflection. American bazooka teams had learned through catastrophic experience that frontal shots against Panthers were suicide, the rockets bouncing off like stones thrown at a battleship. But Kowalski wasn't planning a frontal shot. And he wasn't planning to fire 1 rocket. 6 rockets, launched simultaneously at the thin side armor of a Panther that had committed to the fatal mistake of entering an urban kill zone without infantry support, might achieve what doctrine said was impossible. If the Jeep didn't explode, if the mount didn't collapse, if the rockets didn't veer off in 6 different directions, if the Panthers didn't spot his position first and reduce the entire block to rubble with a single main gun round. The lead Panther, its tactical number barely visible through the snow, ground forward at walking speed, its commander's cupola buttoned tight against the weather and the threat of American snipers. Behind it, 4 more Panthers advanced in a staggered column, their crews confident in the armor that had made them invincible across 3 years of warfare. German tankers had learned to treat American light anti-tank weapons with contempt. The bazookas the Americans carried were toys, nuisances that forced you to keep your hatches closed, but couldn't penetrate, couldn't kill, couldn't stop a properly deployed heavy tank from dominating any battlefield. Kowalski keyed his radio, his voice barely above a whisper. "Command, this is Wrench. I've got 5 Panthers entering the kill zone. Request artillery on my coordinates plus 200 yards. Wait for my signal." The response crackled back through his headset. Artillery was engaged elsewhere. Air support was grounded by weather. The infantry positions were on their own until reinforcements could fight through the chaos, consuming the entire Ardennes front. Standard procedure would be to observe, report, and withdraw. Let the Panthers pass. Hope they ran into something that could actually hurt them. Kowalski looked at his cluster mount, at the 6 rocket tubes angled at precisely calculated trajectories, at the firing wire running back to the trigger mechanism he'd wrapped in electrical tape and prayers. Then he looked at the buildings where 300 American soldiers were preparing to die fighting tanks with rifles and grenades because their anti-tank guns had been overrun in the first hour of the German offensive. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. He'd always been the kind of man who fixed things that weren't supposed to be broken and broke things that weren't supposed to be fixed. Born in Hamtramck, Michigan, on March 23, 1920, Frank Kowalski had learned to weld before he could properly shave, had rebuilt his first engine at 14, and had been running a small machine shop by the time Pearl Harbor pulled him into a war he'd been trying to ignore. The Army had looked at his civilian skills and immediately assigned him to ordnance maintenance, a rear echelon position that kept talented mechanics away from combat and focused on keeping weapons functioning in conditions that destroyed machinery faster than enemy fire. He'd arrived in Europe in July 1944, part of the vast logistics network that kept American divisions supplied, armed, and mobile as they pushed across France toward Germany. His official job was repairing and maintaining the bazookas, recoilless rifles, and portable anti-tank weapons that infantry units burned through at alarming rates. Unofficially, he'd become a man soldiers came to when they needed something that didn't exist in any manual, when standard equipment couldn't solve the problem they faced, when innovation was the difference between survival and becoming another casualty statistic. The idea for the cluster mount had come to him on December 14th, 3 days before the German offensive, during a conversation with a bazooka team that had just returned from a disastrous engagement near the German border. Sergeant Emil Vasquez, a former ranch hand from New Mexico, had described watching his team fire 11 rockets at a single Panther tank during a roadside ambush. Every shot had struck the target. Not one had penetrated. The Panther had methodically destroyed their firing positions with high explosive rounds while the crew laughed over their external speakers, taunting the Americans with offers to let them surrender before being incinerated. "We hit that bastard everywhere," Vasquez had said, his hands still shaking hours after the engagement. "Turret, glacis, mantlet, every angle we could get. The rockets just bounced off or detonated without doing anything. We might as well have been throwing rocks." Vasquez's entire six-man team had been killed or wounded. He'd survived only because he'd been reloading behind a stone wall when the Panther's main gun had found his partner's position. Kowalski had filed the report and then spent 2 days thinking about the mathematics of shaped charge penetration. A bazooka's rocket carried 8 ounces of penolite explosive in a hollow cavity lined with copper. On impact, the explosive detonated, converting the copper liner into a superplasticized jet traveling at 36,000 degrees Fahrenheit and moving at speeds exceeding 25,000 feet per second. This jet could punch through 5 inches of homogeneous armor plate under laboratory conditions. But battlefield conditions weren't laboratory conditions. The Panther's face-hardened armor was specifically designed to defeat shaped charges. The extreme slope of the glassy plate caused many rockets to deflect before detonating properly. And even when penetration occurred, a single jet of molten copper entering a tank didn't necessarily disable the vehicle or kill the crew unless it struck something critical. What kept circling through Kowalski's mind was a principle from his machining days. When you couldn't increase the force of a single tool, you used multiple tools simultaneously. When you couldn't drill through hardened steel with one bit, you used a gang drill with multiple bits working in concert. The armor might defeat one penetrator, but what about 6 penetrators arriving at the same instant, at slightly different angles, overwhelming the target's ability to dissipate the energy? The technical challenges were immense. Bazookas produced tremendous backblast, a jet of flame and gas that extended 15 feet behind the launcher and could seriously injure anyone in its path. Mounting 6 launchers in close proximity would create overlapping backblast zones that might destroy the mount itself. The electrical firing system would need to ensure absolutely simultaneous ignition, because if the rockets fired in sequence, even by fractions of a second, the first rocket's impact would alert the target and potentially cause the others to miss. And then there was the problem of the platform. A standard Jeep chassis was never designed to handle the recoil forces from 6 simultaneous rocket launches. The torque could snap the frame. The weight of the launchers and ammunition would make the vehicle dangerously top-heavy. And if anything went wrong during firing, if a rocket misfired or detonated prematurely, the entire assembly would become a fireball that would consume the vehicle and anyone near it. Kowalski had spent December 15th and 16th in a commandeered workshop behind the lines, working with two other mechanics who understood what he was attempting and why it mattered. They'd reinforced the Jeep's frame with steel plates salvaged from a destroyed half-track. They'd fabricated the hexagonal launcher mount using precise measurements and welding techniques that created a structure strong enough to handle the stress, but light enough not to crush the Jeep suspension. They'd jury-rigged the firing system using components from 3 different electrical systems, testing and retesting until they achieved near-simultaneous ignition across all 6 circuits. The test firing had occurred on the morning of December 16th, using the hull of a destroyed German tank as a target at 200 yards. All 6 rockets had launched within 1/100th of a second of each other. The backblast had been spectacular, a circular eruption of flame and pressure that had knocked both mechanics off their feet and set fire to the grass 50 feet behind the Jeep. But the mount had held. The Jeep had survived, and all 6 rockets had struck within a 3-foot circle on the target side armor, punching holes that overlapped and created a massive cavity that would have been instantly fatal to any crew inside. Lieutenant Morrison had arrived while they were examining the damage, and his response had been immediate and hostile. "Sergeant, you've just created an unauthorized weapon system using military property without proper authorization. You've endangered yourself and your men testing an improving system, and you've wasted ordnance that could have been used by properly trained bazooka teams following established doctrine." Kowalski had tried to explain the mathematics, the tactical advantage, the potential to stop German armor that standard bazookas couldn't touch. Morrison had cut him off. "This isn't a machine shop in Detroit where you can experiment with whatever catches your fancy. This is the United States Army, and we have procedures. Dismantle that abomination and return those launchers to the armory immediately." That's an order. That conversation had occurred at 1,430 hours on December 16th, 1944. 15 hours later, the German Ardennes offensive had exploded across the quiet sector, and Morrison's command post had ceased to exist under a barrage of artillery fire that announced the beginning of what would become the largest battle the American army would fight in Europe. By the time Kowalski had fought his way back to his workshop through the chaos of a German breakthrough, Morrison was dead. Proper authorization was a meaningless concept, and the only question that mattered was whether his illegal cluster mount could do what the survival of 300 American infantrymen required. Now, on the morning of December 17th, with snow falling and Panthers advancing and no help coming from anywhere, Kowalski was about to discover whether desperate innovation could triumph over superior technology, or whether Morrison had been right and the cluster mount was just another way for soldiers to die slightly more creatively than usual. The tactical situation in Krinkelt that morning was desperate by any measure. The German offensive, later designated Operation Wacht am Rhein, but known to Allied forces as the Battle of the Bulge, had achieved complete strategic surprise. 3 German armies, comprising 28 divisions with over 400,000 men, had smashed into the thinly held American lines in the Ardennes forest, exploiting weather conditions that grounded Allied air support and terrain that channeled armored thrusts through a limited number of road networks. The 6th Panzer Army, under SS Obergruppenführer Sepp Dietrich, had been assigned the primary axis of advance through the northern shoulder of the attack, with specific objectives including the capture of the vital crossroads town of Sankt Vith and the subsequent drive toward the Meuse River crossings that would split the Allied front and potentially reach the strategic port of Antwerp. Among Dietrich's most powerful formations was the 12th SS Panzer Division Hitlerjugend, a veteran unit equipped with Panther tanks and supported by experienced Panzer Grenadier infantry. The Panthers advancing through Krinkelt on the morning of December 17th were from this unit, specifically the 2nd Battalion, commanded by Sturmbannführer Arnold Jurgensen, a 28-year-old veteran who had fought in Normandy and understood both the capabilities and limitations of German armor. His after-action report, recovered from German archives in 1948, revealed the confidence bordering on contempt with which German tankers viewed American defensive preparations in the opening phases of the offensive. Weather conditions provided complete operational surprise, Jurgensen wrote. American positions appear to be occupied primarily by infantry with limited anti-tank capabilities. Intelligence indicated towed 3-inch guns and standard bazookas, neither of which presented a significant threat to properly deployed Panthers. The decision was made to advance through the village in column, suppressing resistance with main gun and machine gun fire, while maintaining speed to reach our phase line objectives before American reinforcements could arrive. This assessment was tactically sound based on German combat experience. The Panther's armor protection was specifically designed to defeat American anti-tank weapons. The frontal glacis plate measured 100 millimeters thick at a 55-degree slope, equivalent to approximately 200 millimeters of perpendicular armor. The turret front measured 110 millimeters at rounded angles that enhanced deflection. Even the side armor, at 50 millimeters thickness, was sufficient to defeat most American weapons at combat ranges beyond 100 yards. The American M9 Bazooka, the most common infantry anti-tank weapon, could theoretically penetrate up to 5 inches of homogeneous armor plate under laboratory conditions. But battlefield conditions were never laboratory conditions. The rocket's shape-charged jet lost effectiveness against sloped armor, face-hardened steel, and targets beyond optimal range. Combat reports from throughout late 1944 consistently showed that bazookas achieved minimal success against Panthers when fired at ranges exceeding 150 yards or when striking frontal or heavily angled armor. The infantry positions in Krinkelt reflected these brutal realities. Companies from the 38th Infantry Regiment, 2nd Infantry Division, had been rushed into defensive positions during the night of December 16th as the scale of the German offensive became clear. These were experienced soldiers who had fought through France and into Germany during the autumn campaigns, but they'd been pulled from rest areas and thrust into defensive lines with minimal preparation time and inadequate heavy weapon support. Captain Theodore Walsh, commanding Company K, had written in his hastily composed situation report at 0600 on December 17th. Battalion front extends approximately 800 yards through the village. We have 3 towed, 3-inch anti-tank guns positioned to cover the main approaches, but 2 were damaged during the initial artillery barrage and may not be serviceable. Bazooka teams are deployed in pairs throughout defensive positions. Ammunition supply is adequate for approximately 4 hours of sustained combat. No tank or tank destroyer support is currently available. Request immediate reinforcement with armor or heavy anti-tank weapons. That request would not be fulfilled. The entire Ardennes front was dissolving into chaos as German armored spearheads punched through American lines faster than commanders could track their movements. Reserves were being committed piecemeal to crisis points across a 100-mile front. Communications were breaking down. Units were being cut off. And individual company commanders like Walsh were making life-or-death decisions with incomplete information and inadequate resources. The soldiers occupying defensive positions throughout Krinkelt understood exactly how vulnerable they were. Private First Class Robert Chun, a bazooka gunner from Oakland, California, had survived 3 engagements with German armor during the retreat across France in December. His diary entry from the night of December 16th captured the psychological state of infantry preparing to face Panther tanks with weapons they knew were inadequate. "We can hear them coming," Chun wrote by candlelight in a cellar beneath a stone farmhouse. The grinding of tracks and the rumble of engines carrying through the snow. Miller says we should aim for the engine deck or the rear hull where the armor is thinner. Vasquez says we should aim for track links and try to immobilize them so artillery can finish them off. Kowalski, the crazy mechanic who's been building something in that workshop, says we should wait and let him try something first. I don't know what he's built, but I hope it works better than what we've got because I've fired 17 rockets at German tanks since August, and I've never seen one penetrate heavy armor. Not once. We're infantry with pop guns facing tanks designed to be invincible. The math doesn't work in our favor. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The mathematical reality Chun referenced was stark and unforgiving. Combat analysis from 1944 showed that American infantry anti-tank weapons achieved catastrophically low success rates against German heavy armor. A comprehensive study conducted by the Army's Operational Research Section in January 1945, analyzing data from over 3,000 anti-tank engagements across the European theater, revealed casualty and effectiveness statistics that explained why soldiers like Chun felt they were facing impossible odds. Against Panther tanks, specifically, standard M9 bazookas achieved the following results when employed by trained two-man teams at their most common engagement ranges. At ranges exceeding 200 yards, the probability of achieving armor penetration was less than 5%, with most rockets either missing entirely due to the weapon's limited accuracy or striking at angles that cause deflection without detonation. At ranges between 100 and 200 yards, penetration probability increased to approximately 12%, but only when rockets struck the relatively thin side or rear armor. Frontal hits at these ranges achieved less than 2% penetration rate. At close ranges under 100 yards, where the bazooka's shape-charge warhead could achieve maximum effectiveness, and where gunners could precisely target vulnerable areas, penetration rates increased to approximately 38% against side armor and 62% against rear armor. Frontal armor remained nearly impervious even at these close ranges, with penetration rates below 8%. But these statistics obscured the true cost of anti-tank operations. The same study revealed that bazooka teams attempting to engage Panthers at close range suffered casualty rates exceeding 70%. The requirement to close to under 100 yards meant exposing themselves to the tank's machine guns, to supporting infantry, and to the simple reality that a Panther that detected a bazooka team before the first shot could destroy the position with a single high-explosive round from its 75mm main gun. The two-man bazooka teams scattered throughout the Krinkelt defensive positions on December 17th understood these statistics viscerally, even if they'd never seen the formal analysis. They'd watched friends die attempting close-range shots. They'd experienced the frustration of perfect hits that bounced off without effect. They'd learned that engaging a Panther with a standard bazooka was less a tactical operation than a form of elaborate suicide conducted in the faint hope that lucky shot placement might achieve something doctrine said was nearly impossible. This was the context in which Kowalski's cluster mount represented not just technical innovation, but psychological salvation. If his mathematics were correct, if the simultaneous impact of 6 shape-charged jets could overwhelm armor that defeated single penetrators, if the mount could survive the stress of firing and deliver its rockets with sufficient accuracy, then maybe, just maybe, American infantry wouldn't have to watch Panthers roll through their positions with impunity while men died, trying to stop them with inadequate weapons. The technical specifications of Kowalski's improvised weapon system revealed both sophisticated engineering and desperate improvisation. The mount itself consisted of a hexagonal frame fabricated from quarter-inch steel plate, welded into a rigid structure that distributed firing stresses across multiple load-bearing points rather than concentrating force on a single axis. 6 M9 bazooka launchers were secured into this frame at carefully calculated angles, each launcher offset by approximately 3 degrees from the central axis to ensure that all 6 rockets would converge on a single impact point at the predetermined engagement range of 150 yards. The firing mechanism represented Kowalski's most significant innovation. Standard bazookas used a simple battery-powered electrical circuit that sent current through a wire embedded in the rocket's propellant charge. When current flowed, the propellant ignited and the rocket launched. The problem with firing multiple bazookas simultaneously was ensuring that all circuits completed at exactly the same instant. Even tiny variations in wire resistance, battery voltage, or connection quality could create firing delays measured in hundreds of seconds, enough to cause the rockets to arrive at different times and potentially miss a moving target. Kowalski had solved this problem by adapting the turret traverse control system from a destroyed M4 Sherman tank. This system used a heavy-duty electrical relay capable of switching high-current loads with minimal delay. by wiring all 6 bazooka firing circuits through this single relay and then triggering the relay with a heavy-duty switch salvaged from the same Sherman. Kowalski created a firing system that ensured near-simultaneous ignition across all 6 launchers. Testing with borrowed oscilloscope equipment had shown firing delays of less than 1,000th of a second between the first and last rocket, effectively simultaneous for practical purposes. The G platform had required extensive structural reinforcement to handle the combined weight of a launcher assembly, 6 loaded bazooka rockets, and the massive recoil forces generated during firing. Kowalski had welded steel plates across the chassis frame, reinforced the mounting points with gusseted braces, and added sandbags to the rear of the vehicle to counterbalance the forward weight of the launchers. The result was a vehicle that looked like a rolling scrapyard but possessed the structural integrity to potentially survive the violence of 6 simultaneous rocket launches without disintegrating. The most dangerous aspect of the design was the backblast problem. Each bazooka generated a cone of superheated gas extending 15 feet behind the launcher with temperatures exceeding 3,000 degrees Fahrenheit and pressure sufficient to knock a man off his feet at 20 yards. 6 bazookas firing simultaneously would create overlapping backblast zones that could theoretically create a thermal and pressure event violent enough to damage the mount, flip the Jeep, or seriously injure anyone in the immediate area. Kowalski's solution was brutal in its simplicity. The Jeep would be positioned and aimed remotely, with the crew taking cover in a reinforced position at least 50 yards away. Firing would be accomplished using an extended electrical cable running back to the protected position. If the system worked, the Jeep would survive and could potentially be reloaded for additional shots. If it failed catastrophically, they would lose 1 Jeep and some equipment, but no personnel. Given that a standard bazooka team engaging a Panther at close range had better than even odds of dying in the attempt, trading a Jeep for a shot at destroying multiple tanks seemed like acceptable mathematics. Now, as the 5 Panthers ground steadily through the snow toward the American positions in Krinkelt, Kowalski was preparing to test whether his mathematics were correct or whether Lieutenant Morrison had been right to call the cluster mount a dangerous waste of resources. The Panthers had advanced to within 200 yards of the cluster mount's concealed position. Kowalski had positioned the Jeep in the narrow space between 2 stone buildings that formed a natural alley leading directly onto the main street, with sightlines that would give him a 90-degree shot at the flanks of any vehicle passing through the kill zone. The Jeep was aimed and locked into position using wooden wedges that prevented any movement during firing. The electrical firing cable snaked back through rubble and snow to the cellar position where Kowalski crouched with Corporal Eddie Martinez, his loader, and Private Tommy Chun, the young bazooka gunner who'd written about facing impossible odds. "Range is 190 yards to the kill zone," Martinez whispered, tracking the lead Panther through binoculars. "Speed approximately 3 miles per hour. If they maintain current pace, lead tank enters optimal firing position in 45 seconds. Kowalski's hands were steady now, all the doubt and fear compressed into the kind of cold focus that emerges when theory becomes action and there's no more time for second-guessing. He checked the electrical connections 3 times. The firing circuit showed good continuity on all 6 launchers. The angles were calculated. The mathematics were sound. Either this worked or it didn't, and they'd know which in less than a minute. "Do we tell the other teams what we're doing?" Chun asked, his voice tight with the kind of anticipation that comes before every soldier's first real test of whether training and courage can overcome superior enemy equipment. "No time," Kowalski replied. "If this works, they'll figure out. If it doesn't, they need to be ready to engage with standard tactics." He keyed his radio, speaking to the infantry positions scattered throughout the village. "All bazooka teams, hold fire until after the first volley. Repeat, hold fire. We're trying something new." The lead Panther entered the kill zone, its commander's cupola still buttoned tight, its main gun sweeping slowly across the buildings looking for threats. The second Panther followed 15 yards behind, then the third, fourth, and fifth in a staggered column that stretched nearly 100 yards from lead to tail. They were advancing with textbook German tactical discipline, maintaining spacing to prevent multiple vehicles from being engaged simultaneously, keeping speed low enough to allow precise observation and fire control. But they'd made one critical mistake. They'd assumed American infantry would use standard tactics, firing individual bazookas from dispersed positions that German doctrine could counter. They'd never encountered anything like what Kowalski had built because nothing like it existed in any military manual or training program on either side of the war. Lead tank is at optimal range, Martinez reported. Second tank entering kill zone. Third tank. Wait, third tank is turning, exposing full broadside. Jesus Christ, Wrench, if we're going to do this, now's the time. We've got 3 Panthers and a perfect enfilade. Kowalski looked at the firing switch, at the electrical cable running through the snow, at the Jeep positioned 200 yards away, with its lethal cargo aimed at targets that had killed thousands of American soldiers across 3 years of warfare. He thought about Morrison calling the cluster mount an abomination, about Vasquez's team dying while their rockets bounced off invincible armor, about Chun writing that the math didn't work in their favor. Sometimes the math only worked if you changed the equation. He pressed the switch. The electrical relay closed with a metallic snap that Kowalski heard even from 50 yards away. For 1,000th of a second, current flowed through 6 firing circuits simultaneously. 6 battery charges ignited 6 rocket propellants at effectively the same instant. And then the world exploded. The backblast was spectacular. A circular eruption of flame and superheated gas that formed a perfect ring of destruction extending 20 feet behind the Jeep. Snow vaporized instantly. The stone walls flanking the Jeep's position cracked from thermal shock. Windows that had somehow survived 2 weeks of combat shattered from the pressure wave. The Jeep itself disappeared behind a wall of fire and smoke that made observation impossible for the first 3 seconds after firing. But the rockets flew true. 6 M10-shaped charge warheads, each carrying 8 ounces of penolite explosive wrapped around a copper cone liner, streaked across the 190 yards separating launcher from target in less than a second. They converged on the side armor of the second Panther with the precision of a surgical strike, impacting within a 2-foot circle just below the turret ring where 50mm side armor offered the only practical penetration point for American infantry weapons. The simultaneous detonation of 6 shaped charges created an effect that no single weapon could achieve. 6 copper jets, each traveling at 25,000 feet per second and reaching temperatures exceeding 36,000 degrees Fahrenheit, punched through the Panther side armor at effectively the same instant. The overlapping penetrations didn't just create 6 separate holes. They created a catastrophic failure of the armor plate itself, a massive cavity that let in not just molten metal, but the explosive overpressure from 6 simultaneous detonations occurring within millimeters of each other. The Panther's interior became an instant hell. The overlapping jets struck fuel tanks, ammunition storage, and crew positions with devastating effect. Secondary explosions erupted within the crew compartment as stored 75mm rounds cooked off from the heat. The tank's engine, already running hot from the advance through winter conditions, ruptured as flaming fuel from compromised tanks ignited throughout the engine compartment. Sturmbannführer Jurgensen, commanding from the 3rd Panther in the column, watched in stunned disbelief as a second tank simply exploded from the inside out. Flame shot from every hatch and vision port. The turret lifted several inches from the hull as internal pressure found the weakest escape route. Black smoke poured from the massive hole in the side armor, a hole so large Jurgensen could see through the tank to the buildings on the opposite side of the street. His radio exploded with panic transmissions. 2 is hit. 2 is burning. Where did that come from? I saw at least 4, maybe 6 rockets, all at once. How do the Americans have volley fire rockets? That's our technology, not theirs. Jurgensen's tactical training kicked in immediately. Unknown weapon system. Devastating effect. Immediate threat to formation. Standard doctrine was clear. Identify firing position, suppress with main gun fire, deploy infantry to eliminate the threat. His gunner was already traversing the turret toward the alley, where smoke still rose from the American firing position. But Kowalski had anticipated this response. The moment he'd pressed the firing switch, Martinez had started stopwatch. They had approximately 15 seconds before German gunners could identify their position, acquire a firing solution, and send a 75mm round through the stone buildings that had concealed their ambush. 15 seconds wasn't enough time to reload the cluster mount, even if they'd had the rockets and the courage to approach a jeep that was still radiating enough heat to ignite cloth at 20 feet. But was enough time to trigger the second phase of Kowalski's plan. Throughout the defensive positions in Krinkelt, 9 two-man bazooka teams had been waiting for exactly this moment. They'd heard Kowalski's radio call to hold fire. They'd watched the impossible volley launch from the concealed position. They'd seen a Panther explode from what looked like a direct hit from multiple rockets arriving simultaneously. And now, with the German formation thrown into chaos and commanders focused on the threat they'd just witnessed, every team had perfect firing angles at Panthers that had stopped moving and started rotating their turrets toward the perceived threat. The ambush had been choreographed with the precision of a military drill, because that's exactly what it was. Kowalski had spent December 16th briefing every bazooka team in the company on a tactical innovation that violated every principle of dispersed anti-tank defense. Instead of spreading teams throughout the defensive zone to create overlapping fields of fire, he'd concentrated them in pre-positioned hides flanking the main street, all aimed at a single kill zone, all instructed to hold fire until after the cluster mount fired and drew German attention. The result was 9 simultaneous bazooka shots from 9 different positions, all targeting Panthers that had halted and presented stationary targets while their crews tried to locate and engage Kowalski's firing position. Private Tommy Chun, firing from a second-story window overlooking the kill zone, aimed at the exposed engine deck of the lead Panther. His rocket struck the thin armor covering the Maybach engine compartment and detonated with devastating effect. The shape-charged jet penetrated directly into the engine block, and within seconds, the Panther's rear deck was engulfed in flames as leaking fuel ignited throughout the engine bay. Sergeant Emile Vasquez, the survivor from the disastrous engagement 3 days earlier, fired at the track assembly of the 4th Panther. His rocket struck the drive sprocket with perfect precision, and 54 tons of German armor was suddenly immobilized as the right track separated and flopped uselessly across the snow. The Panther could still fire, could still kill, but it couldn't move, couldn't retreat, couldn't escape the kill zone it had entered with such confidence minutes earlier. Corporal James Wu, a former chemistry teacher from San Francisco, had studied the technical specifications of German armor until he could recite vulnerabilities from memory. He aimed at the vision ports on the 3rd Panther's turret, the small openings that allowed the commander to observe the battlefield while buttoned up. His rocket struck the turret side, just below the commander's cupola, and while it didn't penetrate the heavy armor, the blast effect was catastrophic. Vision ports shattered inward. The commander was killed instantly by fragments driven into the crew compartment at hypersonic velocity. The gunner was blinded by the flash, and the driver, unable to receive commands through the destroyed internal communication system, simply stopped the tank and waited for orders that would never come. Within 40 seconds of Kowalski's cluster mount firing its devastating volley, 4 Panthers were burning or disabled. The 5th Panther, at the rear of the column, attempted to reverse out of the kill zone, but its commander had failed to account for the narrow street and the stone buildings that channeled movement. The tank backed into the corner of a farmhouse with enough force to collapse part of the wall, and in the seconds it took the driver to shift gears and attempt a different escape route, 2 more bazooka teams fired at the exposed engine deck. Both rockets struck within a foot of each other. The overlapping penetrations achieved the same effect Kowalski's cluster mount had demonstrated, catastrophic armor failure that turned a penetration into a massive breach. The Panther's engine exploded with enough force to blow the rear deck armor completely off the hull. Flames engulfed the vehicle. The crew bailed out through hatches, stumbling through the snow as American rifle fire from infantry positions cut them down before they could reach cover. By 08:52 hours, for minutes after Kowalski had pressed the firing switch, 5 Panther tanks sat burning or disabled in the streets of Krinkelt. 0 American casualties had been sustained during the engagement. The entire German advance through this sector of the village had been stopped cold by weapons that German doctrine had dismissed as ineffective against heavy armor. Jurgensen, watching from his command Panther as his formation disintegrated around him, made the only tactical decision that made sense under the circumstances. He ordered immediate withdrawal. His tank reversed at full speed, grinding backwards through the snow while his machine gunner laid down suppressing fire to discourage American infantry from pursuing. Within 2 minutes, he'd cleared the American defensive zone and was broadcasting urgent tactical reports to division headquarters about the new American weapons that had destroyed his company. His radio transmission, intercepted and translated by Allied signals intelligence, captured the shock and confusion of a German officer confronting tactics he'd never imagined Americans would attempt. Enemy has deployed volley-fire anti-tank rockets, possibly truck-mounted or vehicle-mounted systems. Multiple rockets fired simultaneously with devastating effect against side armor. Standard doctrine ineffective. Request immediate tactical guidance and infantry support before attempting further advance through urban positions. 5 tanks lost in approximately 4 minutes. American infantry positions are far more dangerous than intelligence indicated. That transmission would circulate through German tactical networks throughout the Battle of the Bulge, creating a psychological impact far beyond the immediate tactical success. German tank commanders who read Jurgensen's report began approaching American defensive positions with increased caution, slowing their advance and deploying more infantry screening forces. The myth of Panther invincibility, already eroding after encounters with Allied tank destroyers and air support, suffered another significant blow from the realization that even American infantry weapons could achieve devastating results when employed with sufficient innovation and tactical sophistication. For the American defenders in Krinkelt, the immediate aftermath of the engagement was a mixture of jubilation, disbelief, and the grim recognition that they'd survived a crisis that could have ended very differently. Captain Walsh, watching from his command post as 5 Panthers burned in the street, grabbed his radio and broadcast a situation report that captured both the tactical success and the broader implications. Battalion, this is King 6. Enemy armor advance through our sector has been repulsed. 5 Panthers destroyed or disabled with 0 friendly casualties. Repeat, 0 casualties. The Bazooka teams executed coordinated ambush tactics with remarkable effectiveness. Recommend immediate dissemination of these tactics to all infantry units facing German armor. If properly employed with concentration of fire and pre-positioned ambush sites, standard bazookas can defeat Panther tanks. The key is simultaneous engagement from multiple positions targeting vulnerable areas while the enemy is focused on a primary threat. That recommendation would be incorporated into tactical bulletins distributed throughout American forces in the Ardennes within 48 hours. But the specific story of Kowalski's cluster mount would remain classified for months as Army ordnance specialists studied the improvised weapon system and debated whether to develop it into an official program or suppress it as too dangerous for widespread deployment. Kowalski himself, emerging from his firing position to examine the Jeep that had survived 6 simultaneous rocket launches, found himself confronting the physical reality of what he'd built. The vehicle was barely recognizable. The entire rear section was scorched black from backblast. The frame had warped from thermal stress. The launcher mount had cracked in 3 places and would never fire again without complete rebuilding. But it had worked. The mathematics had been correct. The engineering had held together just long enough to deliver a volley that had changed the tactical equation in favor of soldiers who'd been facing impossible odds with inadequate weapons. Martinez approached through the smoke, his expression showing the kind of awe that emerges when theory becomes reality and succeeds beyond expectations. Wrench, that was the most insane, brilliant, completely crazy thing I've ever seen. We need to build 10 more of these. 20 more. Every company should have one. Kowalski shook his head slowly, running his hands over the cracked steel of the mount. Can't build more. Not fast enough, anyway. And maybe shouldn't. This thing is dangerous as hell. We could have killed ourselves if any of those rockets had misfired or if the mount had collapsed during firing. Morrison was right about one thing. This violates every safety protocol that exists for good reason. Morrison's dead, Martinez said bluntly. And we're alive. And those 5 Panthers aren't going to kill anyone else because of what you built. Seems like the mathematics worked out pretty well from where I'm standing. The mathematical reality of the engagement would be analyzed extensively in the weeks and months following the Battle of the Bulge. Army ordnance specialists examining the destroyed Panthers found evidence that multiple shape-charged jets had struck within millimeters of each other, creating a synergistic effect that far exceeded the penetrative power of individual rockets. The metallurgical analysis revealed that the simultaneous impacts had caused the armor plate to fail catastrophically in ways that single penetrators could not achieve, validating Kowalski's fundamental insight about overwhelming armor through concentrated simultaneous fire. But the analysis also revealed the limitations and dangers of the cluster mount concept. The structural stresses on the Jeep platform were at the absolute limit of what the vehicle could sustain. A second volley would almost certainly have caused catastrophic structural failure. The backblast zone was large enough to endanger anyone within 50 yards, including friendly forces who might be positioned nearby. And a requirement for perfect electrical synchronization meant that any failure in the firing circuit could result in rockets launching at different times, potentially missing the target entirely or, worse, creating a chain of misfires that left loaded rockets and launchers that had been subjected to massive thermal and pressure shocks. The official assessment, delivered to Army Ground Forces Headquarters in January 1945, acknowledged both the tactical success and the practical limitations. Sergeant Kowalski's improvised cluster mount demonstrated that concentrated simultaneous fire from multiple bazookas can defeat Panther armor under ideal conditions. However, the system's complexity, danger to operators, and logistical requirements make it unsuitable for widespread deployment. The engagement's true significance lies not in the cluster mount itself, but in the demonstration that coordinated bazooka tactics using standard weapons can achieve similar results through proper positioning and timing. This conclusion led to the rapid dissemination of new tactical guidance throughout American forces. Instead of developing cluster mounts, the Army focused on training infantry units to employ coordinated bazooka tactics that concentrated multiple teams on single targets, achieved surprise through proper concealment, and exploited German armor's vulnerabilities through precision targeting of weak points. The principles Kowalski had demonstrated: concentration of force, simultaneous engagement, and exploitation of momentary tactical advantage, became standard doctrine that would influence American anti-tank tactics for the remainder of the war and beyond. The engagement at Krinkelt on December 17th, 1944, became a case study taught at the infantry school of Fort Benning, where instructors used it to illustrate fundamental principles of asymmetric warfare. A weapon system that doctrine declared inadequate had achieved devastating results because one sergeant had refused to accept that inadequacy as inevitable. Innovation, courage, and tactical sophistication had overcome technical superiority, proving that the side with better equipment doesn't always win if the other side thinks harder about how to employ what they have. For the soldiers who participated in the engagement, the memory would remain vivid for the rest of their lives. Tommy Chun, the young bazooka gunner who'd written about facing impossible odds, survived the war and returned to Oakland where he became an engineer. In an oral history interview conducted in 1992, he reflected on what Kowalski's innovation had meant to infantry soldiers facing German armor with weapons that seemed inadequate. "We'd been told bazookas couldn't stop Panthers," Chin recalled. "Every tactical bulletin, every training manual, every after-action report said you needed heavier weapons. You needed tank destroyers or air support or artillery. We were just infantry with rockets that bounced off." But Wrench looked at that problem and said, "No, the weapon is fine, we're just using it wrong." He figured out that if you couldn't penetrate with one rocket, you use 6 rockets at once. If you can't engage from the front, you set up a kill zone where you control the angles. If you can't survive 1-on-1, you coordinate so it's 9-on-5 instead. He changed the game because he refused to play by their rules. Emil Vasquez, the sergeant who'd watched his team die attempting to stop a Panther with standard tactics, also survived and returned to New Mexico, where he ran a successful ranch. His assessment of the engagement was characteristically direct. Kowalski saved my life and probably 300 other lives that morning. Not just because his crazy cluster mount worked, but because he showed us we didn't have to be victims. We had been fighting scared, knowing our weapons weren't good enough, waiting to die against tanks we couldn't stop. After Krinkelt, we fought different. We set ambushes. We coordinated. We used our heads instead of just following doctrine that didn't work. That's what wins wars. Not having better equipment, but figuring out how to use what you've got better than the enemy expects. The strategic impact of the engagement extended beyond the immediate tactical success. Throughout the Battle of the Bulge, American infantry units employed increasingly sophisticated bazooka tactics based on the principles demonstrated at Krinkelt. Coordinated team attacks became standard procedure. Ambush sites were carefully prepared to exploit German armor's vulnerabilities. Concentration of fire replaced dispersed, individual engagements. The cumulative effect was a significant increase in American infantry's effectiveness against German armor, contributing to the overall defensive success that stopped the German offensive and turned the tide of the battle. German tactical assessments reflected growing respect for American infantry anti-tank capabilities. A captured intelligence document from January 1945, prepared by 5th Panzer Army Headquarters, warned tank commanders that American infantry have adapted their anti-tank tactics to exploit our vulnerabilities. They employ concentrated fire from multiple positions, target weak points with precision, and use terrain to create ambush situations where our armor advantages are negated. Tank operations in villages and urban areas should be avoided unless absolutely necessary, and only with strong infantry support. This assessment represented a significant shift from the contempt German tankers had shown for American bazookas earlier in the war. The weapon hadn't changed. The armor hadn't become weaker. But the tactics had evolved, and that evolution had transformed inadequate weapons into tools that could defeat superior technology when wielded with sufficient skill and innovation. Frank Kowalski himself never saw his cluster mount as the primary achievement of that morning in Krinkelt. In his personal notes, written years after the war when he'd returned to Detroit and reopened his machine shop, he reflected on what he'd learned about the relationship between technology and tactics. The cluster mount was a desperate improvisation that worked once under specific circumstances, he wrote. It wasn't a war-winning weapon or a technological breakthrough. What mattered was the idea behind it. That when you face a problem that seems insurmountable, you question every assumption until you find the one that's wrong. German armor wasn't invincible. Our weapons weren't inadequate. We were just using them in ways that played to the enemy's strengths instead of our own. The moment we changed how we thought about the fight, we changed the outcome. The cluster mount itself was not rebuilt after the Krinkelt engagement. The Jeep was cannibalized for spare parts. The launcher assembly was photographed extensively for technical analysis and then scrapped. No official production program was ever initiated, and no similar weapons were fielded during the remainder of the war. In official records, the engagement appears as a standard infantry ambush that destroyed 5 Panthers through coordinated bazooka fire, with no mention of the improvised volley fire system that had initiated the attack. But the legend persisted in the oral history of soldiers who'd fought in the Ardennes, growing with each retelling until it achieved the status of myth. They spoke of a crazy mechanic who'd mounted 6 bazookas on a Jeep and destroyed 5 Panthers with a single volley. They spoke of German tanks burning in the streets of a Belgian village, stopped cold by American infantry who'd refused to accept that they were outgunned. They spoke of a 4-minute engagement that proved innovation and courage could overcome technical superiority. Some details got exaggerated in the telling. The number of Panthers grew from 5 to 6 to 10. The engagement time shrank from 4 minutes to 1 minute to 30 seconds. The cluster mount became a massive weapon system instead of a crude assembly of welded steel and borrowed components. But the core truth remained intact. American soldiers facing impossible odds with inadequate weapons had found a way to win by thinking harder than their enemy expected. The men who fought at Krinkelt on December 17th, 1944, didn't receive medals or commendations for their actions. The engagement was one small moment in a massive battle that involved hundreds of thousands of soldiers across a 100-mile front. Official recognition went to units that held strategic positions or conducted dramatic counterattacks, not to sergeants who welded bazookas to jeeps and figured out how to use weapons doctrine said were inadequate. But for the soldiers who were there, who watched Panthers burn and survived a crisis that could have ended with German armor rolling through their positions and crushing American defenses, the memory carried a significance beyond medals or official recognition. They'd learned that wars aren't won by the side with better equipment. They're won by soldiers who look at impossible problems and refuse to accept that impossible means inevitable. Frank "Wrench" Kowalski returned to Detroit in 1946, reopened his machine shop, and spent the next 4 decades building custom tools and training young machinists in the principles of precision engineering. He rarely spoke about his military service, and when asked about the cluster mount, he usually changed the subject or made a dismissive comment about one-time improvisations that looked better in hindsight than they felt at the time. But in his workshop, mounted on the wall beside his desk, hung a photograph of a destroyed Panther tank with a massive hole torn in its side armor. No caption explained where the photograph was taken or what had caused the damage. Visitors who asked about it received only a brief response, a problem that got solved. Those who knew the full story understood what the photograph represented. Not a weapon or a battle, but a principle that Kowalski had carried from the machine shops of Detroit through the war and back home again. When something's broken, you fix it. When something needs doing that can't be done the standard way, you find a new way. And when people tell you a problem can't be solved, you question whether they're describing the problem accurately or just describing the limitations of their imagination. The Jeep-mounted cluster mount that destroyed 5 Panthers in 4 minutes was never replicated, never became standard equipment, never appeared in field manuals or training programs. But the idea behind it, that concentrated, coordinated fire from multiple weapons could overcome armor that defeated single shots, transformed American anti-tank doctrine, and saved lives throughout the remainder of the war. Sometimes the most important innovations aren't the weapons themselves, but the new ways of thinking about problems that the weapons represent. On December 17th, 1944, in a snow-covered Belgian village under attack by what was supposed to be invincible German armor, one sergeant with a welding torch and a refusal to accept defeat had proven that innovation matters more than equipment. Tactics matter more than technology, and thinking differently matters more than anything else when the mathematics of survival don't seem to work in your favor. The Germans had called American bazookas toys, ineffective weapons carried by infantry who couldn't threaten real armor. They developed their tactics around the assumption that Panthers were invulnerable to anything American infantry could carry. They'd advanced with confidence born from 3 years of combat success, where superior technology had consistently defeated Allied forces equipped with inferior weapons. They'd been wrong. Not because American weapons suddenly became more powerful, but because American soldiers refused to fight the way German doctrine expected them to fight. And in that 4-minute engagement in the streets of Krinkelt, the myth of invincibility died along with 5 Panther tanks that had entered a kill zone designed by a mechanic who understood that sometimes the deadliest weapon in war isn't the biggest gun or the thickest armor. It's the willingness to see the battlefield differently than your enemy expects, and the courage to prove that new vision works when lives depend on being right. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.